In today's class, we are going to come across the problems on matrices. But before moving on to the theory problems on matrices, first let me tell students that this matrices is not only a important chapter for theory, even it's a very good chapter for our competitive exams as well. You can expect at least 2 questions on matrices in JEE examination and 4 good direct questions in KCET on matrices itself. So, not only theory problems, I am going to speak even few objective questions in this class as well. So, moving on to today's first question, what is that? Let us check it out. Simplify the given expression. What do you mean by simplify the given expression? We are going to get this expression value into its simplest form, So let us check what is that given expression. Cos theta is multiplied into a square matrix of order 2 cross 2 containing the entries cos theta, sin theta, minus sin theta, cos theta. The operator is addition here, plus sin theta into another 2 cross 2 matrix, sin theta minus cos theta, and the last entry is sin theta. So now let us start the solution. First and foremost, I am going to multiply cos theta to every element of the given matrix. Cos theta into cos theta gives us cos square theta, cos theta into sin theta. Let's move on to the second row, minus sin theta into cos theta. This gives us cos square theta, plus as it is. Now multiply sin theta to the second matrix and see what happens. We get the first entry as sin square theta minus sin theta into cos theta. This is what? Cos theta into sin theta, and the last entry is sin square theta, right? Sin theta into sin theta gives us sin square theta, that is equal to. Now the addition operation, let us utilize it. Add the corresponding elements of both the matrices. Cos square theta plus sin square theta, right? What's the first entry? Cos square theta plus sin square theta. What happens to the second element? Cos theta sin theta cancels out with its negative term, minus sin theta into cos theta. So obviously here we'll get it as 0, isn't it? Then moving to the second row, minus sin theta cos theta obviously gets eliminated with what? Plus cos theta into sin theta. So the entry made here, it is 0. Coming to the last entry of the matrix, cos square theta. Yes, what it is? Cos square theta plus sin square theta. Now let us check. This is one of the most important trigonometric identity. If you all remember, what is that important trigonometric identity? Sin square theta plus cos square theta is equal to 1, isn't it? Sin square theta plus cos square theta is equal to 1. In place of cos square theta plus sin square theta, what I am going to write? We are going to write it as 1, 0. This is 0 and finally it is 1. This is the required result of the given expression. We have simplified into one of the important matrix. You all remember, students, which is that important matrix? The answer is, this is nothing but our identity matrix. What do you mean by identity matrix? Once again, a matrix which contains the diagonal elements as 1 and all other elements as 0. So the value of the given expression is the matrix containing the entries 1, 0, 0, 1. Now I am going to take up a second important problem of theory part, and that important most repeated question is this: if x into the matrix 2, 3 plus y into the matrix minus 1, 1 is equal to 10, 5, then we have to find the values of x and y. We have to find the values of x and y. If you are observing the LHS properly, first I am going to multiply x to the given column matrix. It is which type of matrix? It is called as a column matrix containing the numbers 2 and 3. When I multiply this x, what happens? 2x and the next entry is, right, 3x plus, maintain the operator as it is. Multiply y to the matrix y, that is minus y, and this will be plus y, which is equal to 10 and 5 next entry. Now I am going to operate this addition. What happens? 2x plus into minus becomes minus y, 3x. Now I am going to add the corresponding elements. 2x plus into minus gives us minus y. What about the second row, right? 3x plus y is equated to the given matrix. The given matrix, if you are observing students, it is once again a column matrix itself. 2x minus y is equal to 10. 3x plus y is equal to 5. I have equated the first elements of the matrix and let me call it as equation 1. Second element, and this is our equation 2. I am going to add both the equations directly. When I add, what happens? Minus y and plus y gets eliminated. 2x plus 3x is 5x, which is equal to 15. So directly I am permissible to write what? X is equal to 3. See, so easily we obtain the value of x as 3. Now this obtained value of x as 3, I am going to substitute in equation 1. Where is equation 1? This one. 2 into 3 minus y is equal to 10. 6 minus y is equal to 10. Now it is same as me writing here minus y is equal to minus 4. Yes or no? Just check out. 10 minus 6 gives us minus 4. Minus and minus cancels out and we get y is equal to 4. So when two equal matrices are given, we are going to convert them as two simultaneous equations and calculate the values of unknowns here. Therefore, x is equal to 3 and y is equal to 4 and y is equal to 4. Okay, sir. I am going to substitute the value of x equal to 3 as obtained in the given equation. 2 into 3 minus y is 10. 6 minus y is equal to 10 is same as writing minus y is equal to 4. When minus y is equal to 4, what y will be equal to? Y is equal to minus 4. So using the equality of matrices, easily we can find the values of unknowns. Therefore here x is equal to 3 and y is equal to minus 4. Now let us move on to another problem. We are not only finding two unknowns, now we try to find 4 unknowns of the given matrices. Let us check, students, which are those 4 unknowns we are supposed to find here. A, B, C, D. Find, what's the question? Find the values of A, B, C, D such that the two given matrices are equal. Which are those two given matrices equal here? 2A plus B, A minus 2B. 5C minus D, 4C plus 3D is equal to its corresponding matrix with the entries 4 minus 3, 11, 24. So already now onwards you are well versed. We are going to just equate the corresponding elements. 2A plus B will be equated to its corresponding element 4. A minus 2B is equated with its corresponding element minus 3. Before equating the second row elements, I will call this as equation 1 and this as equation 2. So in order to find the values of A and B, what I have done, I have just maintained the first equation as it is and multiplied the second equation with 2. So A will become now 2A minus 4B is equal to minus 6. Then subtract both the equations. Minus plus and minus will become plus. Once I subtract these equations, directly 2A and 2A gets eliminated. B plus 4B gives us 5B, which is equal to 4 plus 6 is 10. Therefore B is equal to 2. This obtained value of B, I am going to substitute in equation 1. Why must we substitute in equation 1? Because we need the value of A. Put the value of B as equal to 2 in equation 1. 2A plus B is what? 2 equal to 4. 2A is equal to, what is 4 minus 2? 4 minus 2 is 2. Therefore A is equal to 1. First row has given us two unknowns, the values of A and B. Now let us move on to the second row in order to find the values of C and D. 5C minus D is equal to 11, its corresponding element 4C plus 3D is equal to 24. I am going to call them as equation 3 and 4 for the further calculations. Observe carefully, not the values of coefficients of C, but if we observe the coefficients of D, I am going to multiply the equation 3 with 3 and maintain the fourth equation as it is. Multiply the third equation with 3. So now what happens? 5 into 3 gives us 15, 3D, and what is 11 when multiplied with 3 gives us 33. I have done over here, maintain the fourth equation as it is. Now automatically minus 3D and plus 3D cancels out when I add them. 15C plus 4C gives us 9C. 33 plus 24 is 57. So therefore, what's the value of C? C is equal to 3. C is equal to 3. Put this value of C as 3 in third equation. 5C it is, right? 5C, place of C, what I am going to substitute? 3. 5 into 3 minus D is equal to 11. Minus D as it is 11. 5 into 3 is 15. 15 plus 15 when shifted to RHS becomes minus 15. Minus D is equal to minus 4. Minus and minus cancels out. So D is equal to 4. So using this operation on matrices, not only we calculated 2 unknowns, even we have calculated here 4 unknowns also. This is one of the important 5-mark question in a PU board paper. So let us check which is that most repeated question of 5 marks. A is equal to 1, 2, minus 3, 5, 0, 2, 1, minus 1. The second given matrix B contains these elements 3, minus 1, 2, 4, 2, 5, 2, 0, 3, and the matrix C is 4, 1, 2, 0, 3, 2, and the last row contains the elements 1, 2, minus 3. So in this 3 given matrices, we are supposed to prove that A plus of B minus C is equal to A plus B minus C. This problem is based on operation of matrices, that is addition and subtraction of matrices. So our task is to prove that LHS is equal to RHS, right students? So when I come to the LHS part, concentrate. Before taking up A into the account, I am going to first calculate the value of what? B minus C. What do you mean by B minus C? We are going to subtract the elements, the corresponding elements of the element B with the corresponding elements of the elements with the matrix C. So B minus C, just concentrate thoroughly. 3, the corresponding element is 4. 3 minus 4 gives us minus 1. Minus 1 gives us minus 2. On the same basis, 2 minus 2 is nothing but what? 0. Move on to the second row to subtract the corresponding elements of B and C matrices. 4 minus 0 is 4 only. 2 minus 3 is minus 1. Be careful with the signs here. 5 minus 2 is 3. 2 minus 1 is 1. 0 minus into minus is 0. Minus into minus becomes plus 2. 3 minus 3 is 0. First I have calculated the value of B minus C. Now Keeping this B minus C, I will take the complete LHS. What is that complete LHS? A plus of B minus C. Substitute the respective values, right? A I have written from the given question, B minus C just now we have calculated, and which is the operator in between? The operator is nothing but plus. Plus implies we are going to add the corresponding elements. 1 plus into minus becomes minus, 1 minus 1 is 0, 2 minus 2 is once again 0 itself, right? Minus 3 plus 0 is minus 3. Move on to the second row on the same basis. 5 plus 4, 9, 0 minus 1 minus 1, 2 plus 3 is 5. What does happens to the third row? 1 plus 1 is 2, minus 1 plus 2 is 1, 1 plus 0 is 1. So now we have calculated the LHS matrix which contains these entries. Now let us check it out with our RHS. For RHS, first I am going to calculate the term A plus B. A plus B means what? We are going to add the corresponding elements of the matrix A with the matrix B, which I have already calculated here. Now this A plus B I am going to subtract with minus C as our RHS demands. What is our RHS? A plus B of minus C. Whatever A plus B we have calculated, I have written down here. Subtract with the minus C with the C matrix. So what we will get? Let us check it out. 4 minus 4 is 0, 1 minus 1, 0, minus 1 minus 2 is minus 3, 9 minus 0 is 9 only, 2 minus 3 is minus 1, 7 minus 2 is 5. Move on to the third row now, right? 3 minus 1 gives us 2, minus 1, minus into minus, be careful students here, minus into minus becomes what? Plus. So now minus 1 plus 2 is plus 1 only. 4 minus 3 is 1. This is our RHS matrix. Now just check whether LHS matrix is exactly coincides with our RHS matrix or not. Yes, it is coincides. Observe, what can I conclude here? Therefore, LHS is equal to RHS. This is one of the important problem for 5 marks. As I already told you at the beginning, this matrices chapter is not only important for our theory, it's also very much important for our CET as well as JEE also. In JEE you will be getting direct 2 questions from matrices, and in our KCET you will be getting 4 problems directly from matrices itself. Such a good point. So in order to crack those questions, I am now here in front of you to tell few shortcuts, few problems on objective questions. This is one of the point that will help us to solve the objective problems which are not directly considered in our theory part. Which are those? Upper triangular matrix, and the second point is lower triangular matrix. Coming to upper triangular matrix, I have just written a general 3 cross 3, a general order 3 matrix of upper triangular matrix. What you can observe here, since it is a 3 cross 3 matrix, right, it must contain totally 3 rows and 3 columns. And not only this, here the elements are like this. This contains 0, all the elements are non-zero above the diagonal array, or all the elements are non-zero above the diagonal array, so only it is called as upper triangular matrix. This is one of the example which was asked in previous paper. This gives us which type of a matrix. When I compare it with the general form, this is nothing but very easy to crack this question, right? This is nothing but what? Upper triangular matrix. How do we identify this is upper triangular matrix? Once again, observe students, the elements above the diagonal array, this is called as what? Diagonal array. The elements above the diagonal array are non-zero. Which are the numbers here? 5, 7, 11, which are non-zero. So only it is called as upper triangular matrix. On the same basis, lower triangular matrix. First, I will just highlight this. This is called as what? Diagonal array. in this diagonal array, the elements below the diagonal array are non-zero. They are what? Non-zero. So only it is called as lower triangular matrix. These two definitions will help us to solve the objective problems. Now, moving with this competitive exams in mind, I have just put one important problem, repeated question, how to solve this type of problem when there are two equal matrices. Two equal matrices. What do you mean by two equal matrices? Equality of matrices. The order of these two matrices must be equal, then only we will be able to equate the corresponding elements, right? A is equal to sin theta 1 by root 2 minus 1 by root 2 cos theta, and B is equal to 1 by root 2 sin theta cos theta cos theta. They have given a condition that the condition is A is equal to B. When A is equal to B, we need to find the value of theta. The given condition is here, A is equal to B, then we need the value of theta. Concentrate on this good question, and I will even tell where the students make mistakes before you could go for the option. Since the condition is A is equal to B, let us equate the corresponding elements. Sin theta is equal to 1 by root 2. This is one of the standard equation in our trigonometry, right? When sin theta is equal to 1 by root 2, students, what will be directly theta equal to? Theta is equal to pi by 4. Here 1 by root 2, it is plus 1 by root 2. Theta lies in the first quadrant, right? Since theta lies in the first quadrant, obviously theta will be equal to pi by 4. But don't be in hurry to mark the option. Check another option with this. I'll just equate the next corresponding element. Minus 1 by root 2. Observe here, right? Minus 1 by root 2 is equal to cos theta. Then whether once again theta will be equal to pi by 4? No, it's not so. Why theta is not once again equal to pi by 4? Because it is not plus 1 by root 2. Yes, what it is? Minus 1 by root 2. Minus 1 by root 2 lies in the second quadrant. When theta lies in the second quadrant, what will be theta equal to? Pi minus pi by 4. You all know the standard format. Theta is equal to pi minus pi by 4. So it is 3 pi by 4. Which will be the correct value of theta? 3 pi by 4, not theta equal to pi by 4. Let us move on to another objective problem. This type of problem already you have come across in theory. In theory you will have a bit of time duration to solve the problem, right? But it is when it is an objective question, time limit matters, time management matters. So now I am going to show it without solving with complete steps how to do this problem. They have equated two matrices. We need the values of four unknowns. Which are those four unknowns? X, Y, Z and W. So how to crack this without much solution? Observe here, x plus y is exactly equal to 4. So we need the values of x and y such that that sum will be equal to what? 4. Already the options are written here. A option is 2, 2, 3, 4. B option is 2, 3, 1, 2 and C option is 3, 3, 0, 1. So x and y you are going to choose from the option such that the sum ends up as 4. Let me move with the option A itself. If this is x, surely this will be y. Add them. Is it not equal to 4? Yes. But I'll show you with the another option also what I have written over here. This is 2 and 3. 2 plus 3 will give us 4? No. Neither. The C option 3 plus 3 is 6. That gives us 4. So I'll come back to choose the A option itself. X plus y equal to 4. If x is 2 and y is also 2, then only I am getting its RHS as 4. Now after finding the values of x and y, after finalizing the values of x and y, let us move on to finalize, to calculate the values of z and w. Just check, where does z and w lies? Here it is z. 2x plus z is equal to the corresponding element 7. Now already we have finalized x to be equal to what? 2. 2 into 2 gives us 4. So z will be equal to what? 7 minus 4. Yes or no? 2 into 2 is 4. 7 minus 4. So what will be z equal to? 3. Z is equal to 3. X is 2. Y is 2. Z is equal to 3. So W will be obviously equal to 4, which is the correct option. A bit is the correct option. Within few seconds we can calculate making use of the given options. Let us check once again whether W is equal to 4 or not. Take the last element, 2Z plus W is equal to 10. Z is 3, 2 into 3 is 6, W is equal to 10 minus 6, which is equal to 4. So X is 2, Y is 2, Z is 3 and W is 4. Using the shortcut without the complete solution, we can opt A as the correct option.